Measuring the time it takes to solve a puzzle in seconds gives us data that is which scale of measurement? Okay, so we have all the basic scales here: nominal, ordinal, interval, and ratio. So let's have a look at what each one of these means. Nominal is categorical data. So I'll just put cat for categories. Now, so is ordinal. Ordinal is also categories, but ordinal is categories that can be ordered. They can be put in order. So the basic difference there would be something like this. It would be, for nominal, I would be looking at male, female. These are categories that people fit into. But for ordinal, my categories would have a built-in order. So something like, if I'm looking at sizes of coffee, small, medium, or large. If I'm looking at degrees, a bachelor's degree, a master's degree, or a PhD. So these are categories that people fit into, but these categories have an order. Medium is bigger than small, large is bigger than medium, and so on. So what about interval and ratio? Well, these two are very similar to each other. In fact, these both are dealing with numerical measures or counts. And you can see here that we do have a measure. We're measuring the time it takes to solve a puzzle. So the basic difference between interval and ratio is not going to be as simple as this. In fact, it's a little bit tricky. Interval is kind of an odd category, whereas ratio is much more intuitive. Now let me just start off by saying that in this case, for this question, we are dealing with ratio data. So why are we dealing with ratio data? Well, because we do have a measurement or a count. We're measuring the time that it takes. And ratio has a meaningful 0. So what do, sorry, let me fix that. So what do I mean by meaningful? Well, this means that 0 equals to none of what is being measured. So if 0 means that there is none of what's being measured, then you have ratio data. So what does that mean? Well, imagine, let's see, what does it say here? It says, measuring the time it takes to solve a puzzle in seconds. What if you've already solved the puzzle? What if at the beginning of this test, you make it known that you actually already have solved the puzzle before they even start clocking your time, before they start measuring the time? Well, then that would mean that the answer here, the actual collected data, would be 0 in your case. And 0 would literally mean that it took no time. But there are some kinds of measures where 0 does not mean that it took that there is none of what's being measured. Usually, the easiest example that's given is temperature. Now, temperature, whether you're dealing with 0 degrees Celsius or 0 degrees Fahrenheit, the 0 points of these temperature scales were arbitrarily chosen, and that means that they weren't chosen because they represent none of what's being measured. When you're measuring temperature, you're measuring how much heat there is. So is there no heat when it's 0 degrees Celsius? Not really. It could be colder. It could be -5, -10, -20, -40 degrees Celsius. Same thing with 0 degrees Fahrenheit. You can go colder. You can't go colder forever. There is a real absolute temperature, a real absolute 0 to temperature. It's called Kelvin. There's another temperature scale, and it's 0 degrees Kelvin. 0 degrees Kelvin is truly the lowest possible temperature. It means that there is no heat whatsoever in whatever it is that you're measuring. So if there is none of what you're measuring, then it does belong in the ratio, in ratio data. Whereas these kinds of temperatures, because you can go lower than 0, you can go lower than 0 degrees Celsius or 0 degrees Fahrenheit, these are interval. Interval means that they lack that meaningful 0. So what about measuring time like we are in this case? Well, like I said, 0 would mean that there is no time, so we do have ratio data.